at this point, what we have with organic reactions is we've looked at one particular functional group, and now we want to expand that into other functional groups. But we also need to not change our perspective, but add a perspective so that we can look at these reactions from a couple of different directions. So for example, what we have right now, or what we've been doing up until this point, is we've been starting with a functional group like an alkene, and we've been doing a reaction to it, and we've been finishing up with some other functional group, which is really what an organic reaction is, converting functional groups. But I can take exactly the same reaction in exactly the same starting material and finishing material, and I can look at it from the perspective of now I'm trying to make that particular functional group, in this case an alcohol. What would I start with and what would I do to that? And realistically, that second perspective here of how do I make an alcohol is a much more important one, because in the world of chemical industry, we're not trying to start with things and do stuff, we're trying to make stuff. Well, what do I start with in order to make that important product? Now, there are other ways I have of making an alcohol, and sometimes one makes more sense than the other. So I have got this reaction available to me to make that alcohol, but I could make exactly the same alcohol using, in this case, a ketone and doing a reaction to that, or I could start with an alkyl halide and do a reaction to that. And we could look at those reactions in terms of the substitution and the elimination and all those different terms that we had for identifying the kind of reaction it is. But the point is, how do I make that alcohol? Ooh, different choices, different reactions, different starting materials. Which one makes the most sense? Well, it kind of depends. It depends on what I have available to me. It may depend on other reactions that I have to do before any of these reactions can happen. But we'll get to that in more detail another time. We've talked about oxidation. Now, the two ends of this oxidation chain aren't particularly helpful to us because we don't have a good way of oxidizing an alkane under control, and oxidizing it all the way to carbon dioxide is also not particularly helpful because now we're kind of stepping outside of the organic chemistry and we've just burned the whole thing. So what we want to do is we want to be able to take, say for example, an alcohol and oxidize that to a ketone or an aldehyde. We can also take that ketone aldehyde, that carbon double bond oxygen, and turn it back into an alcohol. Now, why would I want to do one then the other? I wouldn't, at least not most of the time. But the point is, I could start with that carbon double bond oxygen and convert it to an alcohol. Hey, there's a way of making an alcohol. I can also take that aldehyde in this case and can oxidize that one step further up into the carboxylic acid. And of course, I can also take the alcohol and oxidize that all the way to the carboxylic acid. And understanding the relationship between those three functional groups is actually going to be really kind of important, and also one of the things I find most students kind of forget, at least the aldehyde to the carboxylic acid part. Okay. This is what I was talking about earlier, where I'm trying to make something. Now, I'll usually give you some starting material to work with to give you a bit of a hint, a bit of a starting point. But if I want to take that 2-carbon alkyl halide and turn that into a 4-carbon, what is that? That's an ester, then I need to invent new carbons. No, I don't. What I need to do is I need to be able to take the 2 carbons from the alkyl halide. I need to have a few of those. Now again, with organic reactions, or with any reaction for that matter, the chemical formula that you're given just stands in for that thing. So I'm not just working with one alkyl halide, and I'm not necessarily just making one molecule of the ester. I've got a whole bottle. I've got billions of those molecules. And then the chemical formula that I use just stands in for the one that I'm trying to use. So what we're going to do, and I think the standard way of doing this, at least in my experience, has been to start with where you end up. So we're going to be working our way backwards, this way, while we're thinking forward. And what I mean by that is, how do I make that ester? What is the one step before? What is the stuff I need to use to make that ester? Now, we haven't really talked about it probably at this point, but the way I make an ester is I start with carboxylic acid and I start with an alcohol. And again, the details of that aren't important right now. What's important right now is understanding the thought process. Well, if I'm going to start with carboxylic acid and an alcohol, which is fine, and but that's not the starting material that I have. So each one of those functional groups, the carboxylic acid above and the alcohol below, I need to be able to make those from that 2-carbon alkyl halide. So if I look at the top one, if I look at the carboxylic acid, how do I make a carboxylic acid? Well, I can oxidize an alcohol. I could also oxidize an aldehyde, but a better option is to oxidize the alcohol. Well, how do I make that alcohol? Ooh, actually, by the way, notice that's the same alcohol that I was trying to get. So if I make a whole lot of that alcohol, I can split it. Some of it gets turned into the carboxylic acid. The rest stays as the alcohol. How do I make that alcohol? Well, I know from a previous slide that I can make an alcohol from an alkyl halide. Now again, the details of these particular reactions we'll come back to in class, but the point right now is the thought process of going through this. I want to go one step at a time. I want to start where I need to finish, and I need to work backwards. How do I make that last step? How do I do that last step? Okay, now how do I do the second last step, and so on. Now it seems like we haven't really done a whole lot, and I've got a long list of things you should be able to do. But all of this is going to use, in some cases, the same reactions that we've had, in some cases new reactions, which we'll talk about in class, and then finally a whole lot of practice. But by the end of it, you should be able to do all those reactions and draw the formulas for them, and also plan a sequence in order to make something as a final product. And then after that, yeah, practice is the big thing. Anyway, we'll talk to you in class.